Hello guys, day 19. Today's question, pretty much we get given a list of these workflows, and how a workflow works is that you can think of it as a map where each of the workflows has a key, which is these 2 or 3 characters on the left, and then it has a list of instructions. And you start at the in instruction, and pretty much you go in and you say, is my current S value less than 1351? If it is less, we jump to the PX workflow. If it isn't, we keep going. And then if we get to QQZ, we jump to QQZ. Then say we're at QQZ, we say, is my S value greater than 2770? If it is, we go to QS. Let's just say we do that. We go to QS here and we say, is my S value greater than 3448? If it is, let's just say it is, we go to A. That means we can add our value to the total, and we want to find the total value. So yeah, for pretty much, we get given a list of these Xmas objects where each of them has an X value, an M value, an A value, and an S value. And if you can go through one of these workflows and reach the A value, you add the sum of all these numbers, and if you can't, add 0. Let's look at the code. So part 1, the first thing I did was process the input, which is quite large. So what I did was pretty much, first thing I did was get the index of this empty line, so this blank line in between the instructions, and this I used to separate the workflows from the like the Xmas's, I called it. Then I had got these workflows so I ignored all the lines after and including the break, and for every line before the break, what I did is the first thing I did was I got the first index of this left squiggly brace and then the last index. So I got it in, I pretty much just got all the values in here, which will be the instructions. And then I also took the name, which is just taking the first characters until I get to this squirrely brace. So the name will be the key, and then these values will be a list, which I will store in the value of the map. Yeah, and then inside of these instruction string, which is this bit I just highlighted, I separate it based on the comma. So now I have a list of each of the instructions within a workflow like this. And then for each instruction, what I do is, if it's less than 4, I know it's a jump command. So say, for example, this one is less than 4 characters long, and you just jump straight away. Or this one here is A, it's less than 4 characters, and you know you need to just jump straight, or you need to return a result straight away. So I called these a pure jump. That's probably a bad name for it, but I stored it in this instruction object, which pretty much has a character representing whether it's X, M, A, or S. It has greater than representing whether or not it's a greater than or a less than sign. Greater than would be true, less than would be false. It has a value which is represented by this value here. And it has a jump, which is the value you jump to if the boolean is true. And then it also has this pure jump. And if pure jump is true, that just means that it doesn't have any other variable. It's just like a single thing by itself. Like for this, it would be false. For this one, it would be false. For this one, it would be true. So yeah, that's how I stored it in this instruction object. And then yeah, I just returned the pair, the name and the full, and then the name and then the instructions, and then I associate it in the map. So you can see this gives us a map of string, which is the name, and the list of instructions. So now we have a map of PX to everything inside of here. Then I got the Xmas's values. Pretty much I just got in this thing here. I got rid of everything that wasn't a digit or a comma, and then I just split it by the comma to get the Xmas's values. Cool. Now, once again, I've gone for a classic tail recursive DFS. I've solved a lot of the problems so far using this strategy. So pretty much I keep track of the current instruction, and well, this really should be called current workflow. So then for the current workflow, we go through each of the instructions. And the first thing you do, say, is it a pure jump and of length 1? So if it's a pure jump and of length 1, say for example this A, it means we've reached an accepted value and we can return we can say that this is a viable path. Whereas if we reach an R, we say this is not a viable path. So yeah, if it is a pure jump, which means it's just a single thing by itself, and it's of length 1, we return whether or not it's an A, because this depth first search returns a boolean, which indicates whether or not you should add it to the total. Otherwise, we say, is it a pure jump? And it's not of length 1, because we would have returned already. Then we just jump again. So that, for example, if we got to this CRN, we know it's a pure jump because it has nothing else. And it's yeah. And then we just jump straight away to the next instruction. We don't need to do anything. Otherwise, there's a value we care about. So for example, in this one here, we care about the value A in the Xmas object. So I just map that to a character. And then if the symbol's greater, we say if the greater than value jumps to an A, then we're just going to return true. So let's look at an example here. So this one here, pretty much we're saying if this object immediately jumps to an A, then we will return true if the value's greater than A. Otherwise, we return false. Same thing can be said if it's a false. We'll say if this value jumps to a rejection, then we can immediately return false if this is true. Otherwise, we just go on to the next instruction. So otherwise, otherwise we go to the next instruction. Anyway, I've returned false here. This should never be reached because it should always terminally end on an A or an R. So I just I went through the Xmas's list and I summed up all the values and I got the result. Part 2. So in part 2, it pretty much now says they want to find the total number of possibilities, distinct possibilities. Sorry, I don't know if this can show up. Want to show the number of distinct possibilities all at once. So pretty much you want to simulate every value between 1 and 4,000 for every Xmas values and find the total result possible. Look at the code. So I will admit I low-key cheated in this one. I copied a line off the internet, one line only. So I get the input the same way. And then I have this accepted values range. So pretty much my idea when I was tackling this question was that obviously since the numbers are so large, like the example they give is this number, because the numbers are so large, it means that we have to be a bit more clever about it. And I think the obvious intuition was that we say, pretty much you can imagine we have at every point we have a decision whether we want to go over the amount or under the amount and whether or not they will remain viable. So for example, if we start here at S is less than 1351, we can check, okay, if we say this is true and we go over 1000, and we go less than 1351 and go to PX, if we follow along that path, there will be a sum number of true options. And otherwise, if we go under, there'll be S will now become, 2000, or it'll become the opposite. So you either 0 to 1350 if you choose to go underneath it, or if you choose to go over it, you'll be 1351 to 4000. And pretty much, yeah, so instead of going one value at a time, we'll keep an integer range, or I kept a long range where there's a lower bound and the upper bound. And once we get to the end, if we reach an accepted, we know that the sum will be the total of all the possibilities. So say we get to the end and our values are like X is like from 0 to 787, M is from 0 to 2655, A is from 1000 to 1222, and S is whatever. Like we know that if we get the number range between all these, the low and the high, if we get the distance between those two, we can use that to calculate the total possibilities. I don't know if that made sense, but let's get explaining. So what I did, another DFS function, this is my specialty. But this time I pretty much go one instruction at a time. So you can see here at the bottom, I will call Xmas range starting with a long range between 1 and 4000 and instruction index 0. So what I do is for every instruction, the first thing I do is I check if the instruction is at the very end, that means we're out of range and we can just return. Otherwise, we get the current instruction from the workflow. Once again, we check, is it a pure jump? And the jump length is 1. So this pretty much means if we land on an A, then we want to say that this is an accepted range. And we add the current Xmas range. So we know that these XMAS values, if they're within the ranges, will give us a true result, and we want to add it to the accepted values. Otherwise, if it's false, we won't add it to the range. And then once again, if it's a pure jump just by itself, it means we just need to jump straight again. Then here, this was pretty terrible code, but I don't really know how to do it better. But pretty much we have this old lower bound function which keeps track of what the lower bound was before. Then we have this old upper bound. And then pretty much I have two variables. One is go low and one's go high. So this pretty much says that if we, what are the upper and lower bound going to look like if we go under the current, I guess, challenge, or current greater than or equals check, or greater than or less than check. And then we have this go high, which checks, which returns two Xmas values objects, which represent what would happen if we went above or below the greater than or less than check. Yeah, so pretty much what happens is that within these, if the character, like say for example we're at one of these which is checking A, then we'll X, M, and S will all be left the same, and we'll change A to either be above this or below this. And then if the instruction is a greater, so if it's a greater than sign, the first thing we do is we say, okay, so if this instruction jumps to an A, that means that if we go over it, we're going to get a successful range. So we'll add that to the successful ranges, and we'll try go underneath it as well, see if we get a successful range. Otherwise, if it's a rejection, we know that we have to, if we go high and it jumps to a rejection, we have to just go low. Otherwise, we'll try to do both and see what happens. Same thing for the lower. So pretty much we check if this jumps to an A, we say, okay, it means that if we go low, it'll get accepted, so we add it to the results. Otherwise, we'll just, go high. So once the DFS is done and I have a list of all the acceptable value ranges, which then I call sum of, and then for each of the ranges, I map the ranges to a list, which I made this custom function for. And you might not be able to see it. I have this custom toList function, which converts the Xmas object into a list. And then I use this forward. So starting at 1, we accumulate every time we go through the range, we multiply the amount of possibilities by the size of the current range. That's all. Thanks for watching.